All right. Well, good afternoon, everybody, to our, March 2023 IGIC Lunch and Learn. We have Jay Maxwell and Chris Seeger from, Iowa State. Yep, you're both from Iowa State University, who are going to be talking about R and RStudio. And I just want to remind everyone that we are recording this Lunch and Learn, and we will be posting it to our IGIC YouTube Lunch and Learn playlist and sending that link out in the next day or so. So if you want to share it with someone else or watch it again, that would be how you could do that. And with that, Chris, I'm going to let you and Jay introduce yourselves. This is a very informal group. And do you want questions at certain times, or how do you guys like that?
I think you can ask us questions during. I'm pretty sure you'll have questions at the end as well, but during is fine too.
Okay. If someone does not have a microphone or is not comfortable piping up and asking a question and interrupting the presentation, just throw it into the chat. I'll be monitoring that, and I will be more than happy to find a time during a natural pause to throw out any questions that you may have. And so with that, I will turn it over to you, Chris.
All right. Thank you, Micah. So yeah, good afternoon, everybody. I'm glad to be here, back doing some stuff with IGIC, and Jay and I have had some fun putting this presentation together, both in realizing how much we have recently learned and how much more we would like to learn about using R. So we'll go through a bunch of things here. We both have some demonstrations, and I have some slides to kind of introduce what R is for those of you that might not have worked with it in the past. I was asked by a couple of people if the graphic that was in the email flyer that went out and the code corresponded to each other, and they do. So that was actually the R code used to make, to go grab census data and make this map. And so that's one of the things that we will be talking about here today. So today, like I said, I'm gonna cover some items as far as some terminology for R and the different data structures. I'll be honest with you, when I first started learning R several years ago, when I was first introduced to it, I absolutely hated it. I've only one time in my life been into a technology presentation in which I closed my computer, stood up, and walked out of the conference room because I was so frustrated. And that was with R. And honestly, I think it's because once you get going with it, things do become very easy and standard to do. And when you go and present it, sometimes you forget some certain terms that some of your new people to it won't know what they are. So I'm gonna attempt to try and make that a little bit easier, and not have you close your computer and walk away during this today, and show you some things there. If you have questions about the scripts and stuff afterwards, feel free to reach out to Jay or myself. We're happy to talk you through how we're doing things. There's so many things we could do in R. It's hard to pick and choose what to focus on today. Also, again, there's that 2-question survey. If you didn't get that, Micah, we already sent that out once. But what is R? One thing that surprises a lot of people about R is that it's a language that's been around for a while, since 1993. And it is very well used by statisticians for doing inferences, data analysis, machine learning, algorithm. To a degree, Python might be better. We can argue that. But R and Python, they go back and forth. They're both tools used by data scientists to help them visualize and better understand their data. I think increasingly, though, we're seeing R becoming a bit of a FOSS4G tool because it's free to use, and it's just there's lots of things made to support creating geographical information or visualizing geographical information from it. So when we start with R, you can download and install R onto your computer, and it'll be an application that runs on your computer. And that's why I have this little interface in the top left here. There's a console with it, and you could type into all your coding and text right here at this little console, but don't do that unless you're really like writing code and not seeing anything visual. You want to jump over to a program called RStudio. And RStudio is an IDE that is made by a company called Posit, and it works to help visualize and work with data. Python's been added to it this last year, doing Markdown, HTML, JavaScript. You can do various different languages are supported by this IDE. And it's robust, keeps getting better and better. So go and download that. There are pay options, but for RStudio, but those are usually because they come with support and various other things like that. The RStudio application itself is fully free for you to download and use. Again, if you didn't do that survey, please do that survey. I need the data. Also, I want to show a little proof that this is spatial data science is a real thing. I just saw yesterday on LinkedIn the Nature Conservancy was actually advertising for an applied spatial data scientist. I thought that was kind of cool to be seeing this this sort of position show up more. But what is spatial data science? And a well-known company in the GIS sphere had this definition that's a subset of data science, focusing on the special characteristics of spatial data using modeling to know where and why things happen. I guess I thought that was GIS, but anyway, kind of overlap there pretty close of the two different disciplines, I guess. In terms of the vocabulary, some things that Jay and I'll be talking about as we're showing our code here. I just want to make sure everybody has a sense of what these things are. Variables, if you've worked with other coding languages, you have variables, x equals 5, and you take y and equals x times 3, and y is going to become 15. And so when we code in RStudio, we'll type in code like this and we run it, and in our output area, one of our output areas, we'll see the output gets displayed for us kind of like this. So variables, pretty straightforward, just like they are in most other languages. However, one thing they have on top of variables is they have something called vectors, and a vector is a list. So here I have a variable called DEC columns, supposed to be decennial columns for me, equals, and then there's this C, and then parenthesis around a whole bunch of pieces of data. And I actually do use this in the code later, but this is just a list of elements or items, okay? And they are all, this list is put inside of a variable, but this is called a vector. And a vector has to contain items that are of the same class. So integer, character, date, or a Boolean object, okay? So that's one requirement of vectors, but it's a way of storing this information. We'll also work with a couple other things you'll see we'll be using. We'll talk about packages and libraries. What these are is a collection. When people write code and they put together a bunch of their code, they might make a function that's going to run, and they get all the stuff organized. They'll make a package out of it, all the stuff grouped together. And then you can add that package to R. R comes with something they call base R. I mean, that's the basic coding in R. People have written these packages. You can add these packages. We'll be using one called tidy version of it. And then you add these packages to your environment, and then you load the packages as libraries from that. So install, and then you load a library. The other thing you might hear us talking about is we'll use the word piping. And piping will look like the symbol, the percent greater than percent, or it'll be a bar with a greater than symbol. That's the newer version of writing it. So if you start doing stuff later on, you get confused using all these web resources. I think it's easy to get confused if there's two different symbols for piping. But what piping does is it takes your object or thing you're working with, df, right? It's a variable name. And then it goes and does an operation on that. And that operation, it does another operation, and then another operation. So it's chaining or cascading in other languages, but that's called piping in R. When we're working in R, excuse me, a great resource, you can look this up as well, but R for Data Science, the second edition by Hadley Wickham and Groland, they'll talk about something called tidy data. And with our tidy data, we're familiar with variables, and we have observations. So the variables are this long list of items, and then our variables are the horizontal columns of data. And then within that, each individual cell is a value. That's the nomenclature used in R. But so Hadley Wickham was actually a graduate of Iowa State University, did his PhD work here in statistics, and worked a lot with this thing called tidy data. And in tidy data, it's a little bit different than what we're used to working with when we work in GIS. In GIS, we have a data table, and let's say it's our counties of Iowa, and we have the population, and we have the total income, or all of these different attributes going across in our table. Okay, that's considered to be wide data. Hadley states that they prefer to use what they call tidy data. And in tidy data, each one of those variables becomes a new observation. And so I think I have one of these next here. Oops. And so basically here's a wide data frame. This data is a data frame. A table is called the data frame. The column 2020 would be, there'd be a new row for a DARE for 2020 data, a new row for 2010 data, and a new row for 2000 data. So that's our tidy data. And then we also, this is the regular, it's called the data frame. We also have data frames that are special. They are spatial feature data frames, and those will have a geometry field. And that's how we start to get into the GIS world within R, is by adding this geometry field. Here you go. Here's my tidy data. So 2 columns, we convert them to columns over into rows, and we get a longer piece of information like this. I won't go into that a lot more during the presentation today, but we do that because we can do trend data or time data a lot better if we have it in multiple rows. And the last thing you might hear about is something called tidyverse, and it's just a collection of packages that have this underlying schema that's the same. They've been built the same way, same grammar, they call it. Of how they put data together, so these different packages can work with each other. And this is just like a core set. There's many people have built their packages to work with other packages as part of the tidyverse in R. So, and there, I don't know, Jay, we looked at, there's lots and lots, over, I can't remember the number. It was amazing how many different packages that they have that have been produced. So with that, I'm going to jump into R and show you. I got 3 demo scripts put together, and I watch my time and see if we can actually get through them. But let me clean my screen here. This is where it gets scary, because all of a sudden I go and I revert everything back. All right, so what I have here on this screen is, this is RStudio. I just have it it's in a colorblind version, so I can see the text and everything better, as opposed to white background. But we have comments just like you do in any other languages. So these are my comments here in pink. And then I'm installing these packages. We're going to start out using one package that's made to allow me to read data from Google Sheets. Now I'm going to run this. I can select a line of code and I can hit run. I would go load the package already, but I've already done that today. And so I'm going to load in something called Google Sheets 4, and I'm going to pull in a library called tidyverse. And so brings those in for me. And now I want to load in a piece of data. Now this is an example piece of data that uses Gapminder. It's a Google Sheet somewhere. But if I run this, it goes out to the internet, grabs it. When I bring in data, if it is anything other than a variable, it can get stored over here in my environment. And so here's this one called Gap, and I can expand the little blue button. I can see what the columns are going to be, what type of class they are, character, or if they're a number, and then how many observations and variables that there are. In fact, I can double click or click once on the name of it and open up the table itself and see the table that's in here. And again, this is tidy data. Algeria is repeated every 5 years as its own row. And so you could do all kinds of stuff with that data if you wanted to play around with that. But what I wanted to do is I wanted to go get the data that you use to fill out that survey form for me. So I'm going to run this, and it's going to go grab the data from the form response. We had 23 observations. And so if I open this up and we look at it, this is that was a Google form. Asked you 2 questions. I get timestamp automatically, but I get the 2 questions as to which state you wanted to visit and who you thought was going to go the furthest in the NCAA tournaments for the state of Iowa. And so that data has been pulled in. That was live data. I'd have to go refresh that if I want. If someone just filled that out now, I have to go refresh that. But when I brought that in, this is where we start to use R now. I'm going to show you how we can use R to help us work with our data. We spend a lot of time in R cleaning and fixing things in our data sets so that they can be used. And in this case, my headers, much like you'd see in an Excel file, are terribly long and unuseful. So we can run, it's one line of code, my line 26 here, is going to rename those headers and I'll redisplay it. And so it renamed the headers for me, and now they're called team and vacation. So now that I have that data, there's multiple ways you can pull data in. I had another example here. I'm just going to do it real quick. It brought in another file I had using just a different method. But what was neat here is FIPS codes. If you guys worked with FIPS codes, you know that starting with the number 0 is a real pain. There's ways to deal with that. You tell it what type of column it is. You want it brought in as a character, not as an integer. So you can specify a lot of these things. So what I want to do is that data that we have in vacation and team, I want to count how many responses we have for each of these. And so with one line of code for the NCAA and one line of code for this vacation, and run this. And it went and it made a new variable for me called NCAA_DF. I call it _DF so I know it's a data frame. And so this is, it took this and it made a new value that looks like this. So here's our votes. 10 people thought that the women, Iowa women Hawkeyes would make it the furthest. But let's go ahead now. We can summarize data and keep stuff in tables, but we want to start to visualize the information that we're getting. And so I'm going to do what a lot of data scientists do. I'm going to make a plot. And so all this code here, these are like recipe pieces of code. So you can cut and paste these in, and then it's fairly easy to learn how to use these. And then as you use them, you can start to be able to just write them on your own. But I'm going to run this one. And here's a bar plot showing me some of the results. Now, it's not perfect. There's things need to be cleaned up on it. And I truly, this was when I cut and paste. The only thing I changed was the name of the title and the argument. I left the same with the rest of this alone. But when you start to work with this, you realize, again, there's so many different things that you can do. One of these is make this horizontal instead. So we changed over our attributes here. It said horizontal equals true. And we got a new bar plot. And I should mention, yeah, over in the bottom right here, we have our plots and presentations and viewers. There's 5 different tabs. And so we're dealing with the plots tab at the moment. And so we have this horizontal bar. We can modify it a little bit more. Then I'm going to come down here. And this one, I wanted to fix the X and Y axis a little bit. And so what we can see happened, what I did is I changed it. I changed the size of the names, but they don't quite line up yet. And they're actually off the edge of my page because they're just too long. And so much like we could do when we were recoding data in raster data, I guess I remember recoding a lot of raster data, we can recode our data. Here I'm using the tidyverse and the subset library called dplayer, but I've already loaded those in. So I'm going to scroll down here and I'm going to tell it to recode. So I'm setting ISU cyclone women to equal just ISU and then parentheses W. And so if I run this, it will recode all those values. And if I went back and looked at this, you can see my recoded data. And now we can start to make some more bar plots of this with our data a little bit cleaner and nicer to use. We're supposed to be talking about some mapping here. So I want to take a look at the states that you provided. And we're going to use a basic package. It's a pretty standard package called US Map. And we'll install it and I'll run the library. And the data is currently stored in vacation_DF. That's what we loaded it into earlier. And this is what that data looked like, as after we summarized how many counts there were. So Minnesota had 5. Well, what the maps package lets us do is it lets us directly map this data right to some geometries that are already located in that data set. So I run that, I run this code just to link them together, and now I can plot. And that quickly we have a map. It might not be a perfect map, but showing us a little scale, the default scale, and the all 50 states, and they bring Alaska and Hawaii in because for thematic mapping, the size is important in this case. So we make a nice simple plot, and then we can make it look a little better here using some more parameters of how we're displaying this. So I just highlighted that and I ran that code. It made the changes, and then I tell it to redisplay it. And there it redisplays. So I think if we made this bigger, yeah, it looks a little bit nicer when we're not as zoomed in. Any plots that we make, we can export out and save as an image or a PDF. Other packages give us other options for what we can save things to, but I can save those out and then use them in whatever I need to do. So for somebody that's doing just some basic mapping, R does quite a few things for you without too much effort. A lot of the stuff has got, like I said, easy recipes for what we need to do. Are there any quick questions before I switch into another example of some plotting?
I haven't seen anything come up in the chat. And now's your time, guys.
All right, well, I'll move in. And if you have questions after I get through this one, feel free to ask me. It's kind of a show and tell here. So on the screen here right now, I do have a whole bunch of libraries and packages. And there are a whole bunch out there that you can use with R. And I'm not using all of these, but I like to always have a file started, a temporary file started in which I have these in, and it's easier for me to delete them when I don't need them than it is to have to go back and retype them in. So that's a common thing that I just do, a little tip there that might help you speed up some of your time that you're working on things. But in this particular case, as with most coding, you have to tell it where you're going to be working with your data. And so I got to set my local directory, otherwise it won't find my file. And I'm going to bring in an Excel file called counties_population Excel. And we're going to manipulate this data. Oops, I tell it. So set working directory to the source file location. And to run read Excel because I had not loaded that in yet. So now we can go and we're going to put into counties pop. It's a variable. We just pulled in the entire Excel file. And it's over here on my right in my environment. It's one of my variables. 99 observations, which is good because there's 99 counties, and 22 variables. And if we look at that, you can see that we have this wide data of our FIPS code, county, site name, and then the decennial census population value for each of these counties. But, you know, anytime we make a map of the population in Iowa, of course, our biggest counties are so much bigger than the rest that they can really mess with the thematic map that gets produced. And sometimes you might be interested in more of what's the percentage of the population in a county. And so this week I was thinking about this data issue that I had and was wondering, how can I solve this in R really easy so I can get percentages? And what was kind of fun here was that there are 2 lines of code. Right here I'm highlighting them. And I mentioned that there's this pipe. So I'm going to take my county population. I'm going to put it into a new variable called my county population percent. This is called fail because this one does fail. And then it's going to go and it's going to calculate for me the percentages and put them in those cells. And so if I ran this, if I were to run this now, it would fail because it actually worked too well. I have a FIPS code in here and it actually averages my FIPS code too. So with most things in R, there's another way to do stuff. And if you don't know how to do the simple short version in 2 lines of code, maybe you could do it in 3. And so that's what I did. I told it, and I couldn't quite figure out real quickly how to not do 1 column of data, my FIPS coded data, how to ignore that. I couldn't figure out how to ignore that. But I already knew how to tell it what to include. So I just included the columns that I wanted it to work on. And so this is a vector. And so inside of my DEC columns are all these years. I'm telling it now, I want you to go and work on all of those years. And for all those years, find the percent of the total for that decade of the population. So when we run this now and we look at our counties pop percent, which, what did I do wrong? Sorry, too many tabs open real quick. Let me go back to make sure I had everything loaded. Sometimes don't get everything loaded. One of the nice things, there it comes. One of the nice things about using R is your data is reproducible. I know you can do some stuff in ArcGIS Pro now where you copy your data and you can rerun it, and it will, you can go back and tweak it and rerun it over and over. But it made percentages for me, and now what I can do is, and you can see the percentages here, I can run this and I can get plots of what I'm doing. I'm going to plot out a couple of years here. In fact, you can plot out multiple years and put them side by side. They call these facets. We'll go through these because I got one more script to show you. And there's different layouts. So this is just one way of presenting your data. You can write out your data, save it as a shapefile or as a CSV file. In this case, I do want to work with shapefiles. So I'm going to go to Tiger Census. You guys have worked with Tiger data before. And we can grab our geometry we need from Tiger Census. Except here, you can make sure you go also install the Tigris package. Run all these so I have them. And so I'm going to run those packages to grab that data. Where do I do that on here? One up here. There we go. I'm going to get this Tiger data, run it. It goes out on the web, grabs our data, brings it back. We have a nice map of geometry of Iowa. We can even subset it to just a couple of counties. I'm just going to get the roads for those counties. So here's the roads for 3 of our counties. Again, this is all Tiger data. But when you have that data, you can join it in with your tabular data and start to make plots. So I won't go through all these, but you can plot different projections just using the EPSG number and make different types of plots. And then I said you could join your data. Join my data here. And once it's joined, we can also go and make more maps. And so now here's a map of the population, I said in 2020. Of course, the highest percentage is here in Polk County. But what's kind of neat is real quickly, you can put 2 maps side by side. And I didn't clean this up, I had 2 legends, but you can see 2 maps of 2 different time periods. And you can actually make a whole page of these. We could have gone and done that for every one of the columns of data that we had. And so again, some of the little things that you can do. I showed you a lot of different things, 139 lines of code with lots of comments. Most projects are probably 40 lines of code when I'm doing them. And then the last piece I'm going to do before I turn this over to Jay is one package that you might want to know about, something called Tidy Census. And Tidy Census was designed to go to the US Census Bureau's website and extract data out and bring that data into R. So then you could either save it to a shapefile or you could work with it in R. And so I just had to load the Tidy Census and Tidyverse packages. And we can, I have a whole bunch of examples here, but I want to go see what data is available in the 2021 American Community Survey data. That data came out in December. And so I can load that data in. It goes out and it brings back to me a list of all of the variable names, the labels, and the concepts that are in that data file for the census. So once I know what data I want, the key is this name. We're able to go start using that and being able to go out and get data. So for example, I want the population. So this is the special code that's fun. The population for the year 2010 for the state, at the state level for Iowa. And if I run this, I'll have a pop 10 variable. And it was just over 3 million. Okay, so it goes out and grabs your data, brings it back, puts it into a data frame. Again, you could save this out as a shapefile if you want, because we can include geometry. So it's grabbing that same geometry that I just showed you from Tigris when I had the map of Iowa and I had the roads and stuff. That same type of geometry is being grabbed and combined with the data set that you're getting from Census at the same time. So what is it here? Less than 10 lines of code, including if you're loading the variables in or the libraries in, you could go grab from Census geographic data that has the attribute you need, save it, and then go use it in your ArcGIS Pro or in QGIS, wherever you're working with. So I do that in a few more things here. You run these, let's see what happens. I got ACS population data. Maybe I have a study area of interest. You can pull in multiple variables. So here I'm going to pull in multiple variables. And so I have a variable list, 3 different variables, under age 18, age 18, 24, 16 over. Pull this in and plot it. Oops. Well, maybe I won't do that right now. But you can plot this data. And once you've got it plotted, then again, we can export out the graphic. And I'm not sure what it did plot here. I might not be able to do this real quick, so I'll let Jay talk. But yeah, I'll have to check and see I did something wrong there real quick. But it'll pull this data in, and one of the things then you can do also, which is really cool, I showed this, it can make for you a leaflet map right here in the browser. And then you can export your leaflet map, and I did do that earlier. And so when I export out my leaflet map, this is what that data will look like. I had 3 different age groups, 18 to 24, over 60, and under 18. And these maps are tied together. And you can click on any one and get the pop-up. And so what would have happened if I spent an extra 30 seconds here and found out what I didn't run? You can plot maps just like I did here, or just by changing one line of code from the word plot to the word view, it would have made those leaflet maps I just showed you. So that's kind of what we can do. We've been working through processes doing a direct thing where we bring this right into Postgres and then over to QGIS. And then a similar process is what Jay is using and is going to talk about next for how he's using it to do some of the projects we have here. Jay?
All right, guys, hopefully y'all can hear me now. Let me get my screen share up.
You sound good, Jay.
Okay, great, thank you. So yeah, what I've been doing since joining the team here is automating a bunch of workflows using R. So a little bit about me. I'm a data analyst for ISU Extension. I came back to school in 2019 at Iowa State, and I got a BS in Data Science, and I did the GIS minor. And previous education, I have a journalism and communications degree also from Iowa State University. So I'm just going to kind of talk a couple of the workflows over here real quick in this flowchart form, and then I'll demonstrate 1 or 2 in live code. So one of the first things I did when I joined the team here, I came up with a contact verification script for county contacts that we have for some of our reports. And so we have contact information in a local database, and I wrote a script to pull out that contact information and essentially send up a mail merge style email address to each person in the county, basically to verify that their contact information is still the same. So running this script will send a bunch of emails using my personal Outlook, and then we get responses back, hopefully. The other thing that I've worked on is a data pipeline for our ACS data using the Tidy Census package that Chris has mentioned. So the Tidy Census uses the Census Bureau API to retrieve the data. And then all of our products combined, we need about 205 tables to come from the census data. And that would certainly be a long and tedious process to download each of those individually, clean them individually, and then add the cleaned and prepped product to our database. And so the R script I have will do all that for us using Tidyverse and Tidy Census. DBI and MariaDB, those are packages for database communications, and Glue is kind of a mail merge template, text template type thing, where you have a text template and then you can have some variables inside of that template, and then you can stick inside those variables values from outside. And after all that information is put in our local database, our various data for decision makers products can pull it out. Lately, I've been working on an update to our Senate and House district reports. Because those voting districts have been redrawn, we need to redo all of our reports and all of our data. And this data was a special release from the Census. It was not put on the API for download. Instead, I had to manually download 600 Excel files, and then my script will process those 600 Excel files. Oh, and those are in long format, by the way. Here, let me pull this over onto the screen. This is one of the Excel files. This is the data profile 2 table for Iowa Senate District 1, and yeah, it's a lot of stuff here. And our stuff doesn't really use long format data, so I have to convert that into wide. And my script will take all those files, so essentially 200 Senate files, 400 House Excel files, and I turn them into 8 data profile tables that get put into our database. 4 for the Senate, 4 for the House, and then those are consumed by our local reports. A little more on the mapping side of things. In addition to the data, we also have to have little maps, and I can pull this sample report over here. This is what the report looks like. Every district has a little map up in there, and my new reports need new maps. So I have a script that will take those tiger line files from the Census and make a bunch of little JPEG files, 150 little JPEGs that can be inserted inside of the map. And yeah, so manually download the shape files, which luckily only 2 shape files to download that, one for the Senate and one for the House, process them, output the maps, and they're consumed by our reports. Those are not kept in the database, by the way. Those are just kept in the server. So let me open up my RStudio program here, and we'll do a real quick demonstration on the mapping, since that's what we're all here for, right? Is mapping. So these are the libraries that I use. They are loading up here right now. SF is the simple features library for R. This is the one that has all of the spatial related stuff. There is another spatial library called SP that is a little bit older. SF is kind of newer and a little more tidy oriented, but SP is still a valid spatial library for working with. So I will load up a shapefile. I have a shapefile in R. On the shapefile that I'm using right here, I'll show you real quick in ArcGIS Pro. This is the shapefile of the Iowa districts. I colored them out so you could all see where the district boundaries are in that one. So this is the shapefile that I'm loading up here. And so yeah, it's been loaded up into a Senate districts. There's 50 observations because we have 50 Senate districts. If you want to do a quick looky-loo of the geometry, you can do a quick plot of the geometry there. What type of object is this new variable? It is considered a Tibble, it's a data frame, and an SF object. So any R packages or functions that work with SF objects, Tibbles, or data frames can work with this variable. If I do a union, this is a spatial operation, ST union on the spatial districts, it'll turn it into one, one object. And there's my boundary file for the shape of Iowa. And I also will use a shape file of the places of Iowa, or the cities, the towns in Iowa. And that's what that looks like when you look at it in R. Pretty easy. So I got to do a little bit of cleanup on that first. Not so much cleanup, but data prep. I'm going to arrange it in the order of their size by the ALAND variable. I'm going to add a size order. I'm going to add some label text and an ID that's based on the GeoID, and then I'll kind of rearrange those items based on the ID. And so we can take a quick glimpse at that data, and you see the IDs 1, 2, 3, 4. They're in Senate District order: Senate District 1, Senate District 2, so on and so forth. Down here, this size order, Senate District 1 is the 18th largest district. We're going to do a quick demonstration of district number 12. And normally this stuff is set up in a function, so I can loop through it, but X will be district 12. We're going to work with that. So the district I want, I'm going to use a pipe and filter from my full list of all the Senate districts to just the district I want, district 12. And where's district 12? Right here, one observation of 16 variables. District 12, it does have the geometry column there at the end. I thought that I did a plot. Oh, there is a plot for District 12 geometry. So that's what District 12 looks like. It's in southern Iowa, by the way. This little batch of code here, this is what I have for the file name that will be ultimately produced at the end. And title and rank order, that is some extraneous information that I display on the picture of well. So those go in at the end of the script here. This file will be saved as Senate_district_12. So we showed you a simple plot. We can also do a plot using the ggplot package. And ggplot has kind of a nice thing for plotting geometry. And sort of in its base mode, it will give you the latitude and longitude there on the side, which can be kind of nice. So we're going to build this plot that will be showing here one layer at a time. So we'll make a new plot. We're going to call it G, and the first layer on G is going to be the Senate districts. So if we show G right here, this is a map of all the Senate districts of Iowa. Now, I think maybe this Senate districts of Iowa would look a little better if there was a Iowa border around it. So we'll add to the G object an Iowa border, plot it again, and now we've got a nice little border all around there. We're working with District 12, so I want to add that my single district, kind of highlight that. So we'll add that into it, plot it again. And now we see that we've got District 12 down there with a gray background and a different size border there. We might be nice to label it, so we'll use this geom sf label repel package. I probably didn't have to use the repel package in this one because we don't really need to repel it that much. But the repel will basically push it away from other objects, and I can nudge this one in a little bit. It'll kind of get it out of the boundary. If you just do it default, it'll put it right where the centroid is, and that sometimes covers things up. So if we show the plot again there we got a nice big label for that. And I don't really want this X and Y. I don't want my latitude and longitude information. So I'm going to use a theme, a preset theme that ggplot offers. And theme void is basically a blank theme. So now with that blank theme applied, we basically have the map without the extraneous stuff. We can add some labels to it. That's where we used the stuff earlier on. So now we've got Senate District 12. We've got the label, and then down here at the bottom, this is 50 of 50, meaning it is the largest of all 50 Senate districts. And then I'm going to save that file as a high-resolution JPEG for use in my report, which was this one right there. Now I told you that I usually do have those in a function. So here's all that same stuff in a function, and now I've got this full state map function loaded up. So let's look at district number 50. I can run the full state map of district number 50. I could also run full state map of district number, I don't know, 36. We'll just try that one. 36 is kind of a small one, so that wouldn't be the best case for that one. I have a separate function that zooms in to small ones. If we want to do the 5 biggest counties, we can pull out the county IDs for the biggest counties. There they are right there, and we can run those in a loop, and it will make 5 different maps based on those right there. So based on smaller districts, I showed you that one earlier with 36. This one isn't all that great because you can't really see much detail about it. So we'll kind of step through this again, and we'll demonstrate how I zoom in on the smaller districts. So we'll change X to 22, and we're going to select district 22 here, put that in my district variable. This name, this blank name here is what I use in some of my labels later on. Just like before, we've got our file name, our title, and our rank order that will be used to put this information. And earlier we did look at the places, show the places. Just again, the places data is actually used in this next one. So here's all the cities in Iowa. So what I'm looking at for District 22, I want to find out which cities in Iowa are in District 22, because I want those cities to be labeled when I'm zoomed in on that map. So we're going to figure out which cities are in District 22 by running a spatial operation intersect between my specified district and all the cities in Iowa. We'll do that, and this little pull here just pulls that value out. So if you want to see which ones the district places are, it's still running.
I just wanted to point out, if you're looking at Jay's screen here, you'll notice that he has his environment on the bottom left, whereas I had mine in the top right. The interface is quite customizable, so you can set it up in RStudio the way you like to work, which might be confusing for some of you. As you saw, we had our outputs in different spots, but that is customizable to the way you like it.
Yeah, so here, so my district places right now is a list of the GeoIDs of the cities that fall inside of district, and it's these right here. So now we're going to filter our places layer, make a new spatial data frame of those places, and it seems to have worked. Which cities are inside of the places filtered? Johnston, Ankeny, Urbandale, and Saylorville. So those are the names of the cities inside that places filtered. And I didn't put it in here, but we should also be able to plot places filtered geometry. And oh, it's right below. Yeah, there is the places filtered geometry. So that would be the outlines of Johnston, Ankeny, Urbandale, and Saylorville. Look at them in the ggplot, and there they are again. So now I want to make a bounding box of these places unioned with our district. And so that's what this little command here does. It makes us a bounding box. And just we want to see where that bounding box is in relation to all the districts. The red area right there, that is the bounding box that we'll use to set up our zoom in windowed. These next two steps, I'll be honest, I'm just going to kind of gloss over them. They're used for making the labels later on. And so just like before, now we can start building our plot. So the first plot, the layer is going to have our, just like before, all the Senate districts plus the border. And then we can add the filtered cities. And here's the cities. They're in there kind of small. And let's add the district as well for this. It's in there also, but it's too small, right? We can't really see what's going on. The next step is going to use that bounding box to zoom in to that area. So we'll add that to the plot, and now we've got a nice zoomed in area showing our district in this darker outline with the darker color, and then our municipal boundaries are the lighter gray with the dash boundaries. I know that this coord SF and this ST coordinates, what's going on with that? I'm going to have to thank Stack Overflow for providing the solution for this. It took some looking, but basically the ST coordinates is getting the min and the max of our X and Y values that make up that bounding box. And you can see there for the X values over here and also for the Y values. So those are the max values for that bounding box. So we're continuing on with this label here. Let's add our city labels. So there we have some labels for the cities. And this is where I use the text repel and the label repel on some areas where the cities are small and close together. The labels might bump into each other and overlap each other, and that repel package will sort of push them apart a little bit. Now let's add a label for the district. We've got our district label there, and just like before, we can use that theme, the blank theme. And now we've got Senate District 22. It's the 10th out of the 50 size-wise. And we can see very clearly that it's got part of Ankeny, Saylorville, Johnston, and Urbandale. And so you put all that stuff back into a function, and we can do a district zoom on District 14. It's working, it's processing. Because of the spatial operations, it does take a little bit to run. So there's District 14 with Clive, West Des Moines, Waukee, Adel. District number 10 next here. And again, we could make a loop and make maps for all of the Des Moines districts or anything else that you'd want. It's finally coming up here. Yeah, there's District 10 out there in Council Bluffs. And yeah, that is kind of the mapping showcase of my R scripts there.
Hey, before it's getting to be 1 o'clock, and I wanted to point out to people as you get back to your jobs that there is a form in the chat that Chris and Jay would love some feedback from you guys on this topic. And there are a couple questions. Barry asked, are you generating the district reports with R Markdown? No, Chris, you answered that. See, I'm just kind of reading through. And
we're still using PHP and TC-PDF because we've had that established for many years, but Jay's been experimenting using strictly R and packages in R to produce those. And some of the first steps, I think, or what you saw today with what Jay's doing with being able to manage our mapping, and the data part's actually easier, I think, than what he's doing here at the map component, but we wanted to get that part tackled first. So hopefully soon.
Wonderful.
Yeah, I recommend it. We're doing that a lot at USACE, where we're kind of building custom mapping functions and rolling them into reporting, and our Markdown's probably going to be a good way to do that for you guys. So I definitely recommend going that route if you're interested in streamlining reporting. You can host it on GitHub pages. That way it's accessible. Like, it's a really nice workflow, especially since you're already using R to generate the map products. So
The other thing we'd like doing too is by going to using the Markdown, we can actually start to make more web book type productions and things like that too can come out of that. So yeah, there's lots of
Bookdown's great.
Yeah, Bookdown's great. So there's lots of things to learn. And again, I will say that about R. It's kind of like when everybody first started working with GIS. You remember how they told you how much there was to learn? You'll never learn it all. I think R is the same way. There's just so much you can do.
Well,
Early on, Chris said that he didn't like R when he first learned it, and I will echo that sentiment there. My first class using R, I found it kind of frustrating, and there was definitely a bit of a struggle. But you know, 2 data science courses and 4 statistics courses later, I'm all on board the R ship at this time.
oh, so plenty of hope for us normal people, right? It's a good thing we know you guys as resources. All right, since it is 1 o'clock, I will bid everyone adieu. Thank you so much, Chris and Jay, for presenting on this very interesting topic and a great little side angle to GIS and mapping. I just want to let everyone know that our next Lunch and Learn will be in April. It'll be April 26th, the last Wednesday in April, and it'll be spring. We'll want to get outside. It's going to be beautiful, and so we're going to be talking about field maps. So be looking for that information coming. And once again, if anyone has any questions, please feel free to reach out to Chris or Jay or send myself any of this information, and I will make sure that they get in contact with you. So with that, thank you so much.
Hey, Micah, I just mentioned real quick, we do have some task sheets that we've been putting out there, just like we did on the other GIS products. We got like now 6 or 8 of them, and we have more of those coming. So there'll be just 2-page to help you get started doing some of these things. And then on our CED website, where we list our GIS workshops, we also have some tabs now. One of them looks just at R and a lot of web resources we have found.
Is that what you sent Bailey there in the
Bailey just sent
chat?
that URL. Yep.
Okay, perfect.
So-
I will include that link, and if there's anything else specifically you want me to mention when I send out a recording of this video, Chris or Jay or Bailey, just please let me know. It probably won't be sent out until tomorrow.
Cool. Thank you.
All right. Thanks, guys.